Hey guys. Hopefully everything is good. So to talk about what I guess we're doing today is so I figured out the thing from last stream with the help of honestly ChatGPT. I think that's the main use of fucking AI is when you have to brute force something just to have like constant ideas to brute force it. That does help. It did take like 3 or 4 hours of just trying shit out. But if anyone wants the answer, it's this. So the answer is on the screen. So there's your answer for if anybody ever wants what I was doing, then that's the answer. Now, how it actually works is we basically raycast, but it's not really a raycast. It's like a pseudo raycast to the fragment position. We rotate it into world space. Well, not into world space. This is based on the camera vectors. And then we find this direction, and then we do this. Now, if I'm being honest, I have absolutely no clue why this works. But it does. So I have this is the same thing that we do with our UVs to square it, but like genuinely, I mean, I have no clue why this works. And then this I did come up with myself. And then this gets the rotation for the normal. So this is how we rotate it into the body's own space for itself. Basically, you can think of this is us getting the normal, moving the normal or fake normal into actual like world normal. And then this is us taking that normal and then transforming it by the actual sphere's orientation. And we find the orientation by using the velocity. So it's always facing towards the velocity, and then you just cross the vectors to find the other orientations. And then this is basically what I was doing at the end of last stream. However, you need all of this nonsense to actually transform the normal into real world space. So I was never going to actually figure that out. So yeah. Now, if I ever need to do something like this again, I'll have the code to be able to do it, but genuinely was never going to figure that out. Basically, so the problem is, right, is that we have a sphere with a fake normal, right, that's always facing towards our camera, right? It's just created from quad UVs. Now, the problem with that in terms of actually texturing it is that it does not actually depend on, you know, which side of the face that we're viewing it at. Now, you may just say what I was doing last time was actually just changing it depending on the camera to the center of the sphere, which makes complete sense, right? You just add the normal to that direction and then normalize it. However, you end up with these artifacts, so I couldn't get rid of them no matter what I tried. So there you go. That's how you get the NN, the new normal. Now, is anybody ever going to, you know, find their way into this exact problem. Probably, I mean, maybe not. Maybe this is helpful to someone, but yeah, I mean, I have no clue. Anyway, also, I have a pop out chat today, so I may like not actually. It may not work, so hopefully it works fine. I did figure out that for some reason the stupid fucking OBS chat doc is very, very CPU intensive for some reason. It's just like half of the CPU cost to actually just like pop out my own browser chat, and so that's what we're doing today. So anyway, also, so I did some more research on noise and stuff, and so there are 3 types of noise that is used in terrain generation, and I was doing like the easiest one, right, the Perlin noise. There's also a simplex noise and fractal Brownian motion, which is what this is. And then this is like a famous shader, right? This is in a video by, I'm forgetting his name. I was thinking about this earlier, actually, this video that this is in. He's a YouTuber, right? What is his name? I'm not gonna remember it. Am I? No, Sebastian Log has a video on this shader. I'm like 99% sure that there is a Sebastian Log on this shader. I'm not gonna open the shader because it actually crashes my computer. It just can't run it, which, you know, just shows you, you know, how bad this computer is. But this is fractal Brownian motion. Now, is it expensive? Very much so. It's very, very expensive. However, it is really good for, also hold on. There it is. Okay. Yeah, sorry. I did have to swap my OBS setup again, so it probably does look... It was cut off on the screen, so I'm sorry about that. Anyway, this is the Inigo Quilla's article on fractal Brownian motion. So, anyway, I straight up pretty much just copied this and then added this extra thing here that he does here. Or the F. So the F just, I think, just makes the octaves more vary more, right? Because you have the F that's getting increased every octave. So that's pretty much the idea behind it. And so that's exactly what I did now. So we're not actually pre-computing the textures anymore. However, I guess the idea now that we have this finished, I can show off what this looks like actually. Now that we have this finished, the idea moving forward. Oh, by the way, there's no lighting right now because I don't want to break the computer with lag like I was yesterday. It's just my computer overheats a lot, and so until I can get this HDMI splitter to stream off of the other computer, I just have to be wary of it. So as you can see, that the gravitational like pull of these other bodies are moving each body, right? So that's that rotational spin that I was talking about. That's what we get by dotting the velocity orientation with the normal that we get from the other thing. So that's kind of how that works. So this is what it kind of looks like now. Now, moving forward, the idea is to mesh the planet, right, based on that noise. That's the idea. Now, is that going to be simple? No, right? And so I brainstormed a bunch about like how I'm going to do this. And so that's what I'm going to work on today, is going to be like the first rudimentary kind of attempt at this, right? So here's the thing. We can't just voxelize the whole thing, right? And then just marching cubes it. It's going to be way too big, right? Now, there is also SDFs, right? I was looking at this video on doing like SDFs for planet terrain, because then you don't really have to worry about iterating through the entire thing, right? You just interpolate. So that is also a possibility. Now, is it exactly like the best thing in the world? I don't know. I also like I don't know how to do like SDFs on the CPU if I want to like mesh it on the CPU and then like move over. Like I have genuinely no clue how to do something like that. However, it's whatever. So so this is like the plan, right? So I did like talk with ChatGPT on how to do this, and it came up with this orientation. I think that this is gonna be way too fucking complicated, but basically the idea is, right, to have, instead of just like doing points on a sphere like I was going to do, was literally just like do exactly this down here, what I was doing yesterday, which is basically just iterate over the sphere and then just generate the points on the sphere using this method. What it said is to instead do all 6 faces of a cube and then instead gridify it that way, and then simply normalize the vectors, and then it'll just flatten into the sphere, and then to use those vertices and then use these to input into the noise. That sounds all fine and dandy. The thing is, this is ridiculous. So this is basically, we're going to iterate over the sphere, find x and y, right? This is normalized between 0 and 1, and so we go from -1 to 1, right, to get what this is supposed to be, what we were doing yesterday, to get it in that range. And then so what this is doing, right, is we are pushing out in the direction of the face, right? So this is positive x, so this pushes out positive x. Now you may be saying like, this is super fucking confusing, right? So v and negative u, like, so what does this mean? So if we're going left to right on each face, right, from top left to bottom right for each face, that's fine, right? We can do that. However, what's interesting is when we go on to the opposite face and we're going top left to bottom right, it goes in the opposite direction, right? And so instead of for each face just like saying like, okay, now we're gonna go top left to bottom right, or bottom right to top left or whatever, what we do is we actually just fake the coordinates and swap them like that. So if we're going top left to bottom right here, on the opposite face, that is going to be top right to bottom left. But we don't actually want to iterate in that order. Instead, what we're going to do is just negate that component, so that it is mirrored. Now, is that intuitive at all? Abso-fucking-lutely not. And so this is very confusing, right? So you would think, like, naturally that this is the orientation that we're, like, thinking about here. However, it doesn't really work out that way, just the way that the axes work out. Now, if I had to do that by hand, I would have probably been stuck on that for a few hours. Now, does that mean that we still have to actually do the implementation, but that is very helpful. Now, I don't know if we're going to actually get away with just doing this for the entire thing. I have no fucking clue, to be honest, if this is going to work or if we're going to have to swap these around. I think it's going to be depending on how we do the faces. Also, my music stopped. I just got nons for my music. I don't know why that was a thing. Anyway, so that's the goal. So that was my long-winded explanation of like what I have to do today. So the idea is 6 faces of a cube. You iterate over it, right, uniformly in a grid. Then you normalize those vectors so that we go down on the sphere, and then we use those coordinates, push them as vertices, and then we, since it's all in a grid, then the index buffer is also, we can just like index into that grid because it's all deterministic, all of the vertices. We don't have to spatial hash or do any like fancy bullshit for it. All we literally have to do is every top left of each one is just a quad downward, so 2 triangles. And so when we do the indices, all we have to do is, find the indices and then just like do that in the index buffer. So that's that. Now the problem with all of this is, right, that once we have the mesh, there's going to be duplicated vertices, obviously, on all of the sides, right? That's obvious. Does that matter? I'm not sure. We're going to just have to see how it looks like afterwards and then go from there. So I have genuinely no clue how it's going to look like. Also, secondary. So this is only going to be... we're only going to do this for our selected sphere, right? We're going to generate this mesh for the selected sphere, and then you're going to be able to view it up close. However, this isn't going to give us actual like walkable terrain yet. So there's also that, but we're not even going to think about that yet. This is like the first rudimentary layer, right? And then once we have this, then we, then we can think about collision or something. Basically, this is only going to give us the zoom out, like we're thinking like 64 by 64 by 64, or like 128, like in terms of our resolution, right? We can't actually like, push it to actual like world scale resolution. How am I going to get it so that you can walk around on fucking planets? I don't really know. I think what I'm going to probably do is you have this view, right? Which is our exterior, like zoomed out view. And then you press a button, go down on the planet. And then we basically just do this, but for a section of it at a really high resolution, with the same exact properties that did the noise for the exterior zoomed out view, right? So that's my idea for it. It's kind of complicated, but yeah, it's like the idea is kind of like, Minecraft but no voxels sort of thing. What is going on? I'm just explaining like what I'm like doing today. We're going to be meshing these planets. Basically the selected planet, the I don't know why I pressed escape, but basically the selected planet, like this, when we select a planet, then the idea is that we're gonna like create a mesh for it and then display that mesh instead of just this fake sphere. Sorry about the mic, but so that's what I'm explaining. Yo, bro, it's a long time. Yo, what's up, Brexton? Nice to see you. So that's the idea, is that when we select a sphere, we want to display the mesh for that sphere, because I think that it'll be cool to, you know, see the lighting and stuff. And so maybe, you know, the idea is eventually you press a button and then you're just on the planet. I think that would be cool. However, that's, you know, that's gonna take a lot of work. But anyway, so for like for people that didn't catch the explanation, what I'm doing right now is I'm basically meshing spheres based on noise. I'm going into it kind of blind though, so whatever. I'm going into it very blind, so I don't know what this is gonna be like. But basically, so for right now, we're not actually gonna, I think like we just make a dummy planet and then just render that and then just see if that works. Like I don't think we have to think too hard about it. I think like we just go into this like testing and then not worry about it. I just want to see. Okay. So what are we gonna need to do? I need to create a... I guess it can just take in a particle, and that particle will... Sorry, I'm jumpy today because I had like a third cup of coffee, which was not like my greatest idea ever. I was just tired. So anyway, so we need to iterate over the whole thing in X and Y for each face. Okay, so let's have another function that meshes the face. We also need a vertex buffer, which I was also thinking about, like what vertex information I'm gonna need to do inside of a vertex struct, and like I don't really know. I didn't really resolve that in my mind. I think what I'm gonna do is literally just I think just this. I don't even think we need anything else. Like we don't need texture, you know, UVs or like anything. So I think that that's completely fine. Now it's been a long time since I did like an index buffer sort of thing, so I'm gonna have to set that up as well. I can probably do that now. I have to like kind of remember how to do it though. We're gonna have to make a new VAO and obviously a VBO and an IBO. Obviously. I have to figure out what I'm gonna name it. So calling it a vertex VAO and vertex VAO is probably like, let's just call it mesh for now. It's been a long time since I've actually done the IBO thing. I think that there's like a more, I think that there's a more modern way of going about it. Oh, they call it EBO in OpenGL. Got it. Unsigned 32-bit. GL element array buffer. Got it. Yeah, it's been a long time since I've done that because I didn't even like, I just kind of set that and forgot it the last time I did it. And then for like the last two projects, I like really haven't done it. I did it in the DirectX thing, but that's like, that was kind of different. Okay. Don't mind this this printout that says vertex there. That's not important. You don't need to know about that. Hey man, have a nice stream. Thank you. I hope that you're doing well. Okay. That's exactly what we're doing. Now we also need to... I hate how I did this, but whatever. This is like how all of my fucking OpenGL projects end up. There's a method to the madness. It's actually kind of insane how many compute shaders we have in this goddamn thing. Is this Vim? This is actually Helix. I have a bad computer, so using like NeoVim kind of fucks me up. It's like super slow on this computer. When you have like multiple cursors and stuff. Helix is really fast. That's kind of the best thing about it. So now that we have an EBO and a VBO, I need to make two. I'm just gonna make two global buffers that are gonna be things here. This includes types, right? Yeah. Okay. So I'll just put it in init, or no, I won't. I'll put it in types. I could put it inside of the globals thing, but I'm a rebel. We're gonna have it allocated. I think it's UN32T. I think. So we're just gonna like be really dumb about it and just allocate it and not worry about it at all. On initialization, I'm just like, yeah, we're just going to like hard code allocate it. We're gonna calc this. It's sort of important, I feel like. Now, so how big are we gonna do it? We need to define for that. I think we'll just define it. Mesh res. Let's do really simple 32 first. So this is gonna be, okay, so let's think about this. So for each vertex, it's 32 times 32 times 6 actually. So that's, yeah, because it's for each face. It's not actually cubed. So it's mesh res times mesh res times 6. And this is going to be, we can just do it exactly the same. I'm not going to calculate that in my head right now. It would be kind of painful to do that, to be honest. Okay, so now all we have to do to finish setting this up is make these the same. Or we can just do that when we upload it. We don't have to like think about that too much. What we do have to do is this. To do the VAO. Every time I do this, it's kind of like fucking confusing, to be honest. But let's think about this for a second. So the stride is gonna be 6. Yeah. It should just be exactly this, right? Let's just make a note here. This is pause and then normal, just classic there. And we don't really have to think about it past that. I think that that's just fine. And just to be like sure about this, let's actually just do the thing and just like allocate it. What's the, how am I, why am I forgetting this? It's just GL buffer data. Like how am I forgetting this? So the size is in bytes, right? I think so. Times mesh res times mesh res times 6 is what we just did. But we're really trying to mesh spheres. Yeah, I am trying to mesh spheres. Have you ever done something like this, Ian? In terms of like terrain generation, like procedural meshing? The idea is to have planets that you can walk around on, but I don't know. It's probably hard, but I kind of want to like, I'm just doing like the zoomed out massive planet mesh, like without detail, and then I want to have a button where you can like walk around on it, like kind of Minecraft chunk style, but I don't know. Like that's probably going to be really hard, but I think it'll be cool. I think it's gonna be cool, but I've never done anything like that before. Why did I just do that? This should be correct, right? I'm not wrong about the, yeah, I think that you're supposed to do this the size of, I don't know why I'm forgetting that, but I've not tried isosurface extraction for terrain. I've done is Minecraft style voxels. Yeah, that's what I'm kind of talking about. It's like, it's probably similar to the Minecraft stuff. It's just you just like either marching cubes it, or I saw this video of somebody doing something similar with like SDFs, but I guess it's pretty much you start with the voxels and then you just mesh over it. Like I'm guessing it's like that, but maybe it's just one of these things that I try and then it doesn't work out, because I'm gonna guess that it's not easy. But yeah, I just did the noise yesterday for the visuals on it. So the idea is just to take that information and then mesh it for now. It does have distortion when you're up close, which is annoying. Did I get... Yeah, I did. But the thing with marching cubes is that, like, it scales really badly when you, like, start to get, like, higher resolution. It, like, scales really badly. Because of how branchy it is, it's, like, really... Because there's really no way to vectorize it. So... that's kind of the problem with it. But hopefully I can just like kind of copy and paste it. But yeah. So we're just going to go through all of the faces, and then we just iterate over the faces in X and Y. Thought it's embarrassingly parallel. No, it isn't. Unfortunately, though, so the one... It is, except for the one thing, which is the bit masks for the edges. That's the painful thing, is that there's no way for you to deal with that part, unfortunately. I can show the code, I guess, that I'm referring to. I think it should be inside of here. I can show it. Is it inside? No, it's not in here. It's in mesh. Yeah, so the problem here is literally this. It's just this. That's the problem. Is you have this edge, which is a bit mask that you have to pop off and check. There's actually no way around it. So I tried to make this into a vector, not a vector, but into different registers with literally booleans, and then just parallelize it like that. But it doesn't work out. It's actually slower to do it that way. Oh, the camera's frozen? Oh, I'm sorry. I don't know why that is. Okay, hopefully it's unfrozen now. Thanks for letting me know. But yeah, other than that, you can make it parallelized. Like, I did everything else. But because of that one thing, you have to actually store these out and then not vectorize this one part. And then you go back into the vectorized form for the rest of it. But yeah, it kind of is sucky for that very reason. Now, if you like do this on the GPU, you can probably get away with doing it on the GPU in like a more, you know, like parallel form. But obviously that project, I didn't have a GPU, so that was the kind of challenge. But maybe I do this on the GPU now instead of, and then it'll be faster. Because, but then the problem is all of the race conditions and atomics at the end with when you actually push the vertices. Then there's like kind of that issue as well. So there's a lot of issues with it. I was about to say online, it seems GPU accelerated marching cubes. Yeah, it's probably like literally that is the reason. It's because of that specific reason you can't vectorize the whole thing. But maybe there's a way on the GPU where it's like not bad. But anyway, that's the sucky part about it. I feel like you can just go to mesh res, right? But I haven't looked at any like GPU implementations. I'm sure that they're out there. I looked at one, I think, from like this math library. I don't really remember what it was, but you can do loops on the GPU. It doesn't necessarily mean the algorithm isn't. Yeah. Yeah, it's not. I mean, the algorithm itself, like from the exterior, is embarrassingly parallel because they don't like inherently affect each other, if you mean like that. But in terms of like CPU wise vectorizing it, you can't do like plus equals 4 here. That's what I'm talking about, right? There's no way for you to get around doing that. So that's what I was kind of meaning. But I don't know, so the problem with it is that like I don't know how they deal with pushing vertices. Like it's like an atomics issue, I feel like. I mean, there's definitely a way around it, but I would have to look at an implementation because that's the main problem. Also, a problem with marching cubes was the normals was kind of sketchy. Like vertex deduplication was kind of painful with 8 threads. Like I would have no clue how to make it thread safe on the GPU. That's kind of the problem, you know? Like something like this, for example, where you're like averaging the normal into a vertex that you've deduplicated. Like I have no clue how to make something like that thread safe. It's like inherently not thread safe, you know? So that part kind of sucks. There's probably, once again, a way around it, but it's not, you know, a simple thing at all. So now you need to get this into is it mesh res -1? We just like make them floats, not volatile floats, but just floats. It might be mesh res -1. I think it's mesh res -1. Okay, so now that we have that, we need to normalize it between slotted into the thing, right? So Yeah. Okay. So now that's between -1 and +1. And now you just... Right, now you have to do the thing that I was talking about earlier. Now you have to do the this thing. Okay, so I'd say that we just like... Okay. Okay, so I'm just literally going to do this. It is in the same order. I have no clue if this is going to be the correct orientation. We're just gonna have to like literally try them all out because I have no way of actually knowing. It's just like completely random. I have literally no clue. That's the thing that I hate about Helix, is that one fucking thing. Okay. Okay, let's just do this the fast way. Okay, well that isn't the fast way. Okay. Yeah, I have genuinely no clue if that's gonna work, but you know. Okay, so that gives us the pause, and now all we have to do is normalize the thing to get it on the actual cube. Is that it? I think that it's literally it. And then from there we just iterate through all of the faces. Is it gonna allow me to do this? That would be nice of it. That's very nice. It doesn't allow you to do that on the standard that's on Windows XP, that's for sure. What NVIDIA article? A lot of them are. Like the one that I had to read on linear bounding volume hierarchies is fucking... I don't know how they do that stuff. It's fucking nuts. GPU terrain generation with marching cubes. Send it in the Discord. I'll take a look at it. I probably could have looked it up. I'm not like there yet with it, but I guess that's my plan. But I definitely have a lot of stuff to, you know, finish before that. Yeah, let's just take in let's just take in this, and then let's just do it this way. We're not gonna worry about normals for now, because this isn't gonna be the final implementation anyway. So let's just not even. Do I know mini RT project? No. Should I? I'm sorry if I don't know it. I'm your G. Thanks. I'm glad I'm your G. What do you mean it's indented too deeply? Can you shut the fuck up? Dude, Clanged is such a square, bro. Like, literally just, like, let me write my own goddamn code the way I want to write my own goddamn code. Do you know what I mean? Like, come on. Okay. So, we're just gonna call mesh face on all of the faces. Okay, got it. So we mesh all of the faces, and now what's the thing now? What is the thing now? Now we have to do all the indices. The thing is, can't we just do the indices per, like, during the meshing of the faces, since we don't have to go across? This is all deterministic. We could literally just do it. Will I calculate shadows and intersects? I'm not sure about intersects, but in terms of, like, shadow mapping, probably, like, definitely not now on this project, but I mean, normal base shadows, I guess, already exists, kind of, but there's no, like, specific logic for it. What's up, QL? I'm wondering, do I make this a special function, or if I just do it here? Yeah, the reason why we have this O here is that's the offset for the face. What version? Oh, this is 4.6. So it's new OpenGL. But I'm not like using any of the fancy features yet, you know, just SSBOs. I also, so this GPU is so bad that I can't even use subgroup directives. It's just not thread safe on it for whatever reason. Fuck NVIDIA. But yeah. The last one indeed. Half of the features I can't use though, so that kind of blows. We can just do it here and just cheat. The vertices won't be ready for us, but because they're my GPU is fine, my GPU is not fine, Kiel. It's a fucking laptop mobile GPU. My GPU is not fine. It literally can't do subgroup directives because it's Pascal. It supports it, but it doesn't actually support it. Trust me, I've done the tests. It's because I can't use latest drivers. I had to downgrade my drivers myself because my GPU is old. God bless Linux, right? On Windows, it's fine. But no, yeah. Mine has 2 gigabytes VRAM. Do you think mine has any more than that? Look it up. Let's look it up. Let's look it up. It has 2 gigabytes of VRAM. So, and it's a mobile version, which means that when my laptop overheats, as you've seen it do many times, it literally will just not work. So it sucks. It sucks. I can't do anything on this computer. This program, by the way, runs at this frame rate, which is probably about like 200 frames per second. However, because of the overheating problem, I can't actually do any more than this. So I can't actually read 60 FPS because if I push this simulation any further, then my GPU will literally not work. So that's the shitty thing about it. But yeah, my GPU is not fine. It's notoriously shitty. Would consider to work in a job. The thing with that is that any money I get goes to the US government because of my school loans. So it's kind of damned if you do, damned if you don't sort of thing. But whatever. C'est la vie. Obviously you don't have to do this. Hey, what's up, Max? How are you doing? I'm doing just fine. I'm doing absolutely just fine. All right, let's think about this. Is this correct? No, it's not correct. You need obviously 2 triangles. So that's gonna be that one, and then down one, and then you have the other one, which will start, if we're doing the same vertex ordering, it's gonna start there and then go there, yeah. New project? Yeah, it's a space simulation. It looks like this. This doesn't have lighting though. So. It doesn't have lighting because I turned it off, so that's why. But the idea here is that I want to mesh the planets themselves. So that you can walk around on them. That's the idea. That is the idea. Just so that it matches. Okay, I have no clue if this is correct, but I'm just going to assume that it's fine. Yeah, the normals are going to be the problem. I'm the master in graphics. I'm not the master in graphics. If I'm the master in graphics, then I would be able to read any of these NVIDIA papers, and they would also hire me. If I was the master in graphics, I would probably have, more than, a few viewers on the stream. C? Yeah, it's C. Yeah, I mean, I don't know how to do the normals, but maybe we just don't even worry about the normals for now. Anyway, this should actually just have the buffer now. The thing is, the x, y, these coordinates are obviously not scaled. Okay, here's a good question. Do I actually scale this before I normalize it or after I yeah, after. Why am I fucking dumb or what? Yeah, so let's just do it separately. Let's just, so by the radius, so let's just do like a radius of 300, and that should be good. Now the question is, how do I actually... Oh yeah, am I being dumb? If I have this many indices, then I need it times 6. So I need to change the size of that. I'm just gonna give it headroom. Because it would be pretty embarrassing if I just ran out of space. That would be pretty embarrassing. Okay. I have to include. What is that? What the fuck is that? Alright, so we included it, and now all we literally have to do is call it and with a particle test. Actually, nothing actually is based on the particle value, so I didn't actually write anything based on the particle value, so. Okay, so this is just gonna mesh the planet and put it in the buffer. So I guess the idea is just to get rid of all of the other bodies, just so that we can just see one body. So that's what I'm going to do now. I'm just going to get rid of literally every body. And then just render the one. The issue is that we need a different... We're gonna need another shader. That's kind of cursed, but yeah, we do need another shader. It sucks because it does suck. It does suck because the lighting is gonna have to be done 2 times in a row, and also also our selection texture is also fucked now, like royally. Yeah, I don't know. I don't know how we're gonna do it, but we'll just cross that bridge when we get to it. Okay. Okay, let's get the boilerplate. Yeah, we don't need that boilerplate. I think, so this is what I think. I think we just go super simple with it for now. And we don't really worry about, we'll just grab the UBO with the camera data and get this. Just grab this. And just, I think we're just gonna go with that. Like, what else do we really need in this? I hate how it does that. It's super fucking annoying. We can just grab this, and then that's pretty much gonna be it. It's not a velocity. It's actually gonna be a normal. A normal, more like me. What else do we need? I think nothing. I think nothing is what we need. I think I'm just gonna send color with it. and then just set it to nothing. What does that sound? Oh, it's that. Okay. All right, that sounds good. So now inside of here, we don't need that, but whatever. Let me get the thing. All right. Okay, so for right now, let's actually just go. Let's just do that. I'm not forgetting anything, right? And just do that for free. Like there's nothing stopping me from doing that, right? I think it's fine. So in init, we're gonna have a new shader now. So I have to make a new shader. Okay. And then I have to initialize it over here. Okay, so, the viewport, blah, 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 blah. We're just gonna draw it on the same FBO. Find mesh VAO. Do mesh shader. Don't need any uniforms. Yeah. I think the draw buffers is fine as well. I think literally all we need to do is this now. I think so. We have to. That's fine. That's fine. Is it draw elements instance or just draw elements? That's a good question. What is the count? Yeah, that's a good question. And what is type? I have to look that up. So that's really the type of the values in indices, right? Just unsigned int. Okay, got it. Unsigned int, and then the indices is mesh indices. Oh yeah, I have to upload that as well. Just upload it once. But before that, we need to figure out the count. Honestly, I think I'm just gonna set a global variable that to like just a global variable for now. Just so that we know. Yeah, so I count, let's just make these global, I guess. Like, I don't fucking know, just make them global for now. Just make them fucking global, man. And that way we'll just go. Okay, and then that will be, we'll just do the classic I count divided by 3. And that mesh indices isn't actually the EBO. It's mesh EBO. Oh, I guess you just put in the thing. It's instead, you don't have to upload it. Oh, well, that's neat. I guess that's neat. Maybe. We have to upload the vertices though. We can just upload it once. After we mesh it, just go to, it should be exactly that. Wait, hold on. Oh yeah, it is size of. Oh, it's because of the sub data. It doesn't have usage, yeah. Okay. Why is it mad at me? Too few arguments, expected 4. Oh. Oh, offset. Right. Okay. So technically if I did this correctly, that should be it. That should be it. Draw elements should technically just go based on this. I don't know, I haven't done this in forever. We might like segfault. Okay. Oh. I didn't make. There's a fucking stupid little. It's not a fly, it's just one of these tiny fucking bugs flying around. Dude. It's like one of these stupid fucking tiny little gnat bugs, man. Ruining my whole day. I didn't allocate it, or I didn't declare it, so. Oh, undefined reference. Yeah. I'm all over it, man. Okay. This draws seems a long time. And I don't see anything. Oh no. Core dumped. Oh no. Okay. Let us try and figure out what the problem is. We can try, like, just getting rid of this. There's no reason for us to... We did use programs, so that's fine. I may have just forgotten how to do this. Element array buffer. That is what I forgot. Okay. I'm fairly concerned that we're going to, like, crash the fucking computer. But whatever. Is it elements instance or not? Oh, I see. A byte offset into the buffer. Okay, got it. Yeah, that's what I was confused about. A byte offset into the buffer. That should be it. So I do have to upload it to the EBO. Oh, also, I didn't do this, which is another mistake. I didn't do sub data for it, did I? Or, I mean, I didn't allocate it, did I? Down here, I did, and I gave headroom. All right, and it's 10. Might actually not. We can literally just go to iCount. Yeah. Okay. Okay, hopefully I know what I'm doing here. Which I don't know what I'm doing at all, but I think that's fine. Okay. Okay. All right. All right. Okay. That's pretty funny. That is pretty funny. Interesting. Interesting. Huh. I don't think I triangulated this right, the indices. I don't know, something's just telling me that I didn't. Something is just telling me that I didn't do that correctly. However, I mean, it did draw, so that is correct, I guess. So I passed this, so that's... I do set that to 0, right? I do set v count, and I don't set it to 0. So that might have something to do with it. Okay, that did not have something to do with it, actually. Thanks, compiler, for setting that to 0. Thank you. Always got my back. Okay. So maybe this is wrong, but it looks almost correct is the thing. It looks almost correct. Okay, so here's something. Yeah, so we don't want to be doing that on the last rows. That is true. That is true. This is the correct stride, right? We go across an X. Yeah. Yeah. Okay, so that got rid of the going across thing. Okay, this is interesting. So it looks like it's sliced like that. If I had to guess, it's the indices that's wrong. Do I have a graphics related job? No, I do not. Are you offering me one? If so, thanks. If I had a graphics related job, I'd probably be able to figure this out immediately. That's how it works, right? I'm hella smart. I'm not hella smart. But thank you. Suppose that's n equal to c negative. Face plus plus. Yeah, so this is strange that this... Because it should at least be doing the extra faces. But it doesn't seem to be... It doesn't seem to be... Let's try not scaling it. I mean, it's going to be incredibly tiny. It's weird that we only get 2 faces of the sphere, though. Yeah, we only get 2 faces of the sphere. So where are the other 2 faces? Ah, fuck, dude. Did this gnat just fly into my eye? Is that what that is? Like, what the fuck? What? Bro. That's fucking whack. That is the wackest thing I've ever fucking heard. Maybe it's y plus 1. Maybe it's a winding thing? I don't think it is a winding thing. If it was a winding thing, it wouldn't look like that. Let me think about this. So if we're going... No, it would be that way. Wait, hold on. No, yeah, it is. Yeah, it's... And then... And then it would just... I don't think it's a winding thing. Why don't I find a job in a software engineering field? I'm talented and smart. Thanks. I have been looking. I made a portfolio recently. If you want to see it, I can pull it up. This is my portfolio. And I made a business email. However, I don't know, it's kind of hard to find a job with, and 1, the current job market, 2, my skill set is very niche, you know? Like, I'm good at making, like, graphic simulations, experimental shit, you know? Like, I'm not like a ray tracing guy, so it's kind of hard. But it's not like I haven't been looking. It's just hard. Like, I don't have a degree. I don't have like the most amazing work history. I also haven't worked on like any like project with like other people. Like, all of my projects are kind of me in this room working on it alone. So most recruiters, employers are looking for something else, I think, to be honest. So thanks, I appreciate that. I really do. Let's print out... Hold on. Let's look at this. It's 100% this, I feel like. Here's something. Let's literally just make a cube and then go from there. And then like let's see if it's here or not. Or no, that's not a cube. No, that wouldn't be a cube. Okay, let's just not normalize it then. Let's just not normalize it and then go from there. We can also try like web development or AI and machine learning. Yeah, I could. I mean, but like also that's not what I really want to do. You know? Like I've had plenty of jobs doing things that I didn't want to do, and that shit just makes you miserable, you know what I mean? That shit just makes you very miserable. And also web development and AI and machine learning are just so oversaturated with people. It would be way, honestly, like easier for a job to kind of just like come my way of like something that that's my area of specialization. Yeah, exactly. Because like a job opportunity for me is like, it's either something is going to 100% suit my skills or not, you know what I mean? Like there's no competition for a job that I would have, if that makes sense. Okay, so let's try not negating anything. Let's try not negating anything. Because we don't care about the noise right now. So let's just try not negating anything. We don't care about like orientation. Yeah. This should just march across naturally. Okay. So it's not. Then that probably mean like that probably means that it's on the drawing side, to be honest. Like it's probably something to do with this. I probably made like a stupid mistake. Yeah, let's follow through with what I was gonna do here, which is just like literally print out. Just literally print that out. That's definitely the correct amount. It's definitely the correct amount. I have a feeling like this is wrong, actually. Even though it looks completely right. How old am I? I'm 25. I don't think that dividing it by less is gonna do anything. Times 2 minus 1, that's correct. Yeah, the thing is, it's only, so I think that the two faces that are getting emitted are just X and X. just x positive and x negative. And so the other two faces are just getting collapsed onto that. I'm almost at the point of like doing that and just seeing if it is that. Okay, got it. Okay, so that's the lower half of it. Got it. How many hours do I code per day? It depends on the day. Like sometimes I go through stretches where I don't code at all. Like where I get like super just out of it with it. But then there are some days where I, you know, obviously, like most of the time it's like 6, 7, 8 hours. Most of it doing bullshit like this. Yeah, this is kind of shitty. It's kind of annoying because I haven't used shit like this in a while. It should be, no, I definitely did unsigned int for all of that, right? Like this should just cast to, this should just automatically cast to UN32T. I don't have to do anything with it. And this is definitely UN32T. So that's definitely correct. Also, this is supposed to be mesh dried, but they're exactly the same anyway. This is correct. Element array buffer is correct. And that's correct. Yeah. Mesh res times 6. Yeah, that should be enough. That should be it. That should be it. So the initialization is fine. And this does seem absolutely fine. And I think that that's what you're supposed to do. This const void pointer 0 for the byte offset. Have I gone to college? Yeah. Yeah, I'm constantly reminded of that fact. Yeah. I have. I enjoyed it, I just never I never finished. I regret it, you know. What have I studied? I studied music composition and then linguistics. I was always kind of into art, but I don't know. I think that this is -1. It probably is how I'm doing the indices. I wonder if doing them in a separate You know what, maybe we should just like do the raw vertices at this point. I just feel like that'll be maybe even more complicated than just doing this, but yeah, I mean, we could just like do the raw, this would be -1 because you're not going to do the last, one if you do this. And so, yeah, so let's just do emit the entire quad, I guess, and just cheat it. So I'm just gonna not do it with an index buffer just to isolate the problem, and then we'll go back to doing it with an index buffer after I isolate the problem, because I'm not gonna sit here for forever fucking staring at it. Whatever. We're gonna do x plus 1, and then oh, we have to do 6 of these. Fuck. I don't want to write an abstraction for a debug thing. That's fucking stupid. Okay, I'm not going to write an abstraction thing for the fucking thing. I'm just gonna do it 6 times all the way down. And then this is going to be y plus 1. And then I'm not going to forget to change the size of the verts. I'm not. I'm just letting myself know now that I'm not. That's +1, and then this is both. Switching from art to this. Yeah, I mean, I started programming when I was in high school, and then I stopped. It's kind of just, I like moved to New York, and then I just like fell into a music production thing, and then from there I just didn't do any programming. I think it is -1, yeah. And then so yeah, so that should just work, and then we have to go here, and now this is ×6 × 6. It should be ×6 × 6. That should be the amount. And then the amount of triangles is just v count divided by 3, right? And Jill, you went first. Okay. Okay. So technically that should just work. I also have to allocate the buffer itself to ×6. Interesting. Okay, so let me try something now. I didn't set this to, but also that's not correct. That was not correct. And this orientation thing shouldn't matter, because that's only, it shouldn't. All right, peace out, Rexon. Thanks for hanging out. I hope you you have a nice one. Yeah, so this is exactly what we had before, so let me check the shader real quick. I don't know. Just for any hint. Maybe I'm missing something stupid. I mean, I 100% am missing something stupid, but I feel like you should just be able to, like, for this debug shader, it's literally just that. So I don't think that that's a problem there. Hey, what's up, Sad Sam? How are you doing? Let's try not doing that. Try not doing that. Did I fix that texture bug? I did. It took me fucking forever though. Oh, weird. It took me fucking a lot of brute forcing it. Right now I'm working on I'm trying to mesh the actual spheres, but I'm running into some stupidity issues. That's what I'd call it, stupidity issues. I mean, this should not matter. That should not be it. Man, it's something so stupid. It is something so stupid. Why can I not draw a fucking cube? Like, actually. Okay, I guess I'm just mesh the spheres as created the vertex data for yeah, that's what I'm doing. I'm just gonna do a debug version of this where I just go to here in integers and then just do the runs, and then there will be no funny business. Yeah, we'll just literally do ints. And no like division or any of that bullshit. And then there'll be no Do I plan on doing LOD? Yeah. Yeah. Well, the plan is to just like have this version that's just like the zoomed out version, and then have like one that like have the full mesh when you're at the surface. I don't know if I really plan on doing like LOD because it's gonna be expensive to just mesh the selected one anyway. But then again, that's just what I plan and not what's probably gonna happen, so I don't know what it's gonna look like. I feel like I'm in the fucking Twilight Zone. Hey, what's up, Nigma? Nice to see you again. It's been well. I finished that project that I was doing. A lot of simmed went into it at the end. So it was pretty crazy, but it turned out good. I hope what you're working on is good as well. Just to eliminate all extra shenanigans here while I'm trying to figure this out. It has to be in cube pause at this point, but the problem with that is like, how could I be messing this up even? Like, if this is 1 and these are out by that much, I mean, technically it should be 32 because that's mesh resolution in the case that we're doing this right now, but like, how could I even be messing this up? Like, actually. Oh, wait, no. It's going great as far as programming. That's awesome. That's good to hear. That's what matters. Whoa. Whoa, what is that about? What is that about? What is that about? What? Switching this to V count apparently just bugged everything the hell out. That is an int that I do initialize to 0. 100%. So unless I don't know how GL triangles work, I think that oh, wait a second. Nah, you shouldn't have to bind the VAO. You shouldn't have to bind the VAO. You shouldn't. Quantum triangles, yeah. I'm honestly, so it's very strange. I'm having trouble drawing a cube right now, which is something I've really never had problem drawing before, but it's probably something that I'm just like not thinking of. I guess. Like, let's just try to do two faces, I guess. I don't know why that's bugging out. Like, what is that about? Why is it so far away? Oh, because I did 32 times 300, that's why. I did 32 times 300. That's actually, so the reason why that was doing that was because that's actually our view plane going out of range. That's why that was happening. Okay, so I do know what's happening now. So this going x positive and then x negative, these are just going next to each other instead of across from each other. And the reason why that is because you have to center them around 0. So this is a necessary thing. Or actually, every mistake is just a refinement, yeah. I said the far plane too close. Well, I just like multiplied it times 300. So it was just really far. That's why. It's just really, really far. So we could recenter it around 0, but I don't think that that's actually going to fix the problem. Like if they're I'm this close to just printing out the points themselves because that's kind of what I'm gonna do, I guess. I'm just gonna sample 1 point on it. I did not expect to have problems with this part. Okay, that's exactly what I expected. And this should be positive 32. So positive 32, 1. And then negative 32, 1, 1, 1. So why is that? Why it looks like a folder icon? Good question. Good question. So what's happening is that, so we have these two planes, right? One at positive 32 and one at negative 32. But for some reason, what's happening is that the positive 32 is it's on the same plane. It's on the same plane. So that's interesting. That is very interesting. Something about the camera orientation? That would be pretty crazy. That would be pretty crazy. I don't know. Maybe it has something to do with the camera matrix. I don't know. It should just be proj view. It should just be proj view, like. I'm shooting violently. Yeah, I mean, thanks for. I'm gonna figure this out eventually, and then I'm gonna like be really mad at myself. Is what's gonna happen. This 0 is supposed to be 0, right? Normalize, yeah, 100%. And I do have the VAO here, 100 billion%. $100 billion%. Oh, dude, it's always like something stupid, man. It's always something stupid that gets you. Maybe I need a knot. I don't think that would be it. And I am... Yeah. That's all correct. Everything is correct. No, it's gotta be my vertices. It 100% has to be the vertices, and I'm just like not thinking about something correctly. I don't know how this program is structured. Yeah, so basically what I'm doing is I'm just literally iterating through X and Y, which obviously I'm iterating it correctly, right? Both go to 31, right? So this... I think maybe I'm thinking about this actually incorrectly. Oh, wait a second. No. Make a test triangle with static points. Yeah. Yeah. Yeah, I mean... I'm trying to think like how do I debug this? Like how do I debug it? Because obviously the points themselves are correct. Like this is gonna give us the actual triangles. Like this, and this is 100%, you know, these are valid triangles, obviously. That's your projection of view matrix. Yeah. Here's something that we can do. Just to get unstuck here and like mentally reset. Like let's, instead of doing all of this, let's just create one giant triangle. Just two giant triangles, right? Let's just do God, I'm gonna be kicking myself once I figure this out. Let's just do 0, 0. Let's do 0, 0 for, and then just 32. Yeah, so this is gonna be that, and then this will be 32, which is the top right corner, and then you have 32, 0. Okay, and that's literally just going to be it for the two phases. And what we're going to see is we're going to see two triangles next to each other instead of across from each other, and we saw nothing. Well, that's, if you count 6 and we didn't draw anything. Why didn't we draw anything? Why didn't we draw anything? Wait, what? How are we not drawing anything? Okay, okay, like, I'm just gonna hard code the points, I guess, and then see from there. What? God, this is so fucking frustrating. Wait, what? Did I do something here? Unless we have a new problem. This is like this is what like this is just it's just a massive triangle, dude. That's just a massive triangle. Let's try just one massive triangle. Dude. Okay, now I'm thinking like I must be uploading this wrong or something. Like I must be uploading the buffer wrong at that point. Like what? V count is guaranteed 6. Oh no, it's 3. Divided by 3 is 1. So we should be drawing a triangle, sir. Like what? Hold on. Maybe me I did put this line of code in there before we compiled like huh. And this is fine. This works fine, but that doesn't work. I mean, I'm just so confused. See, that's what we were supposed to see. Was that giant triangle. That's what we were supposed to see. So why? Why? So okay, so here's what we're gonna do. We're gonna lock in here and we're just gonna get rid of sim step. Just get rid of sim step and just render. Because there are no bodies. We don't want anything touching it. We don't want anything touching it. We don't want to be touching that right now. This is fucking so confusing. I don't understand. Why can I only draw many triangles and not just one triangle? Like what? Like, how did I mess this up? Vertex is pause and normal. It's absolutely. Maybe I messed up this type somewhere. Maybe I just. I mean, let me just do that. Like, oh man. No. Yeah, I mean it works, like the shader works fine. It's just like how is this like let's just like do v count equals 0 just to like make sure it's like maybe we just like don't do sub data just to like make sure that it, I don't know. I mean, like, God, dude. I mean, at this point, I'm just like so confused. I'm just like hard coding it. Like, what? Oh, right. I need v count equals. Like, that's the same code. That's the same code. That's the same code. That's the same code. I mean, like, what? I say we just, like, start the entire code base over at this point. Let's just delete the whole thing. Like, what? Like, what are we doing here? I mean, like at this point, it's just. Maybe, okay, so maybe we're just tripping ourselves up here. Maybe like, maybe it just literally can't draw. Maybe like the GPU just literally can't draw one triangle, like, or something like that. Like maybe it just has a problem drawing one triangle for whatever reason. Maybe that's just the truth. I mean, it shouldn't be the truth because that shouldn't be the truth at all because I mean, yeah. Dude, this is gonna drive me up a fucking wall at this point. I don't know. This is very, very annoying. Yeah, I mean, might be something in my setup that just causes it to not work with one triangle for like whatever reason. It's like, okay, now nothing is working though. How did I break everything though? Okay, well, GPUs can have dyslexia. Yeah, I mean, I guess so. Oh, it's because I'm. Is it because I? What? Oh, it's because I'm only drawing one, and not v count divided by 3. Yeah, that's definitely a peculiarity for sure. Anyway, like whatever, right? Let's just do two of them side by side regardless. Like let's just forget about the whole thing and then just like do this. Why? Oh. Just to see it. The autocorrect of ASCII emojis. Yeah, that's awful. That's awful that they do that. Okay, are you fucking kidding me? Okay, so this goes side by side. This went side by side. Wait, so if that goes side by side, then why does this not go side by side? Let's count. 1, 2. That is 6. And they both have the same winding orientation. No, they don't. They don't. They have opposite. They don't. They don't. It's supposed to be this. This. It shouldn't. Maybe it does. Maybe it does matter, but maybe it does matter. They're messing with me for amusement. Yeah, I feel like that's what we gotta. That's what we're landing on here, to be honest. I don't know how I messed this up. So this is from 32. X and Y going across. And X and Y going across, and every time we add, we're adding 1, so add 1, then down and add 1, and then right in that direction. No, in this case I was right about the winding. Actually, it is the other winding, because you're starting and then there and then there. So that winding is correct. What would be cursed is if it's this switch case that's the problem, like for whatever reason. That would piss me off. That would piss me off indeed. Let's just like hard code the return, because like I don't know anymore. I just don't know anymore. Okay, that's us hard coding the return. Like, why I had a switch case there? Because that's for each face. So you can think of this as like one face that face, that face, that face, right? They're all in opposite directions, so they have a negative and then positive. So that's why, because they don't want to just, you know, duplicate the code. You know what I'm thinking of maybe at this point is that this is not the right way to do this. Maybe I did this wrong. I'm just gonna get rid of the normal, just so that I can make sure that the stride is correct. Because I have a feeling that, I mean, the fact that for whatever reason one triangle doesn't work and that there's just like funky shit going on, I have a feeling that I set up the stride wrong somehow or something like that. I have a feeling for some reason that that is the case, but it wasn't a float, it's an enum. Face is an enum. No, that's the exact same thing. Get rid of the EBO completely. I don't know. I mean, story of my life right now. Provide integers for the actual floats. I mean, they're all. I mean, this is just for debugging purposes. There's no other reason for it. Hold on a second. Let's try something. So let's try. Let me try that. Why does it only cover half of the... Wait, hold on a second. Mesh res is 32 though. Mesh res is 100% 32. So why is it not the same size? Is what I'm wondering. Because technically it should go to 32. Should go from 0 to 32. Delete all the comments. That's probably true. I could delete all the comments. I just don't want to have to rewrite the same code again. But yeah, I could just delete all the comments. Sure. I don't know. Here's an idea. Let's just so here's what I feel like. It's not drawing all of the triangles. That's what I feel like. So this is the problem. Here's the problem. So you see here what this is telling me, this here, that's the triangle that it stops at. So none of the rest of it is getting drawn. That's the problem. That's exactly the problem. But I don't know, like, why it's not all getting uploaded to the VBO. Like, maybe we just gen it and then don't like null it out and then just try to allocate it later. That's nothing. Why does this not work? Oh, did I do this wrong? No, I didn't. No, it definitely is a very simple, it's a simple problem. Like, there's something, how many triangles? So it's 32, it's just 32 times 6. Plus the 2 debug triangles that we have. So let's just try oh, this is so fucking stupid. Let's try subdata-ing it. This is not the right fucking buffer. It's gonna be something stupid, man. It's gonna be something so stupid. So the offset is 0, of course. I'm pissed off, so I'm not doing it properly. That should be it. We call init, then we do mesh planet. That's the order of operations. We do init and then we call mesh planets. Okay, so that's still happening. So let's try just v count times 2. Like, is it v count that's not correct, or what? I don't think that it's that. You know what? I'm binding something wrong, or I'm counting something wrong. Oh my fucking god. It's that? Are you serious? Okay. That's a fucking tilter. Bro, so the reason why I did that in the first place was because we were coming from index buffers, and so I just like naturally divided it by 3 instead of like using my fucking brain. Like but this is supposed to be the triangle count, not the vertex count, right? Or is it? Maybe it actually isn't the. I don't know. I don't know. I don't know. So yeah, we can call it brain fog for sure. Okay, so now why is this not? Oh, because I hard coded the face. Okay. I did not expect to spend all day doing that. Okay. So that's a cube, but these aren't cube. Why are these too far? Why are they too far? Why are they too far? Get rid of these now. Why are those other 2 ones too far? So this is one of those things where it's like now you figured the bug out, but while you were figuring the bug out, now you just made a bunch of bugs, and now you have to figure out how to. Oh, it's just too much. It's just, yeah. Oh, yeah. It's just too much. It's not supposed to be -32 to -32. It's just supposed to be to 0. It's just, if I do this, then they'll come together. Because we're not centering around 0. It would be 16. Yeah. there. The reason the corners don't line up is good question. Why don't they line up? Whatever. Let's not even worry about it. Okay, so now that we have that figured out, that still doesn't actually, so that was all debug. That was all us debugging it. It's not actually supposed to be a vertex buffer, it's supposed to be an index buffer, obviously. So that was all debug. So now we know that we can draw a cube. Okay, here's something. So let's not even go there yet. Let's just try to do it with this. Before we involve the index buffer. Let's just do it with this. All right, peace out. Enjoy your coffee. So let's try to do it with this. These go back to floats because they need to be between 0 and 1. Okay, so we had it like this anyway, so we just have to copy them all the way down, which like does really suck. Actually, let's just do it by hand. It's fine. Okay, let me make sure that we do this correctly. 1, 1, 1. Yeah. Weren't allocating the correct amount. Yeah, it wasn't allocating. It was just that I was drawing the wrong amount. Yeah, that's interesting. Why am I iterating from 0 to 1? Because we're gonna normalize them and then push them onto the cube. Is what we're gonna do. Okay, so let's think about why this isn't. Oh, I don't normalize them every time. Because it needs to be from -1 to 1, because then we're going to normalize the vectors and then it's going to become a sphere. That's what's going to happen. Okay, so we made a cube. I don't know why the edges don't line up exactly. Not sure. But that's the cube. I think it might be because we're supposed to be going to -1 if we're doing this like this. So I think that's like that. And then from here we just normalize it and it should become a cube. And then now that this is fixed, now we can do the index buffer. Does it actually iterate? No, it iterates in integer space. But I just wanted it to be a float because I don't want to have to cast it every time I divide it here. That's why. So now it's a cube. Okay, so that's correct. So this was exactly what we had here. It's exactly the same thing. Exactly the same. So there was nothing wrong with what we had originally. There's nothing wrong with it. And we can prove it right now by going back to that function. We can prove it right now by going back to that function. We can also go into and put the thing back for this. And also put this back since we know that that wasn't the problem. And Now just put everything back and then just prove that it works fine, because it should be the exact same thing as beforehand. And this v count is getting set to C, and that's completely fine. Okay, let's try it. What are those numbers in the background? Individual frame render results? Yeah, it's just, that's just our debug. Our not our debug. Our that's just our time for each part of our calculation. It makes you feel any better. A couple of months ago I tried to implement a quaternion. Octonian. I don't even know what that is. I have no clue what that is. You got me on that one. Per implement 40 objects. That's insane. That is crazy. That's way above what I'm capable of. So you got me on that one. Okay, so let's try not scaling it. Like, how is this any different from what we had previously? How is it any different? It's the exact same thing now. It's the exact same thing. Let's try doing v count directly. It should be, this is the exact same code. So, and now before I even know it, I'm learning group theory. Yeah, I have no clue what any of that is. That's some quantum mechanics crazy talk. Octonians is crazy. I know I'm saying crazy a lot, but that's just genuinely how insane that math is to me. I would not know how to do that at all. Okay, now I'm starting to think that something is different here, fundamentally different here. Is the winding different? X plus 1, y plus 1, y plus 1. X plus 1, y plus 1, y plus 1, x plus 1. That the winding is the exact same. And this is the exact same. I mean, this is so crazy, no? It's kind of the gist. The hard part is trying to visualize the relationship. Can't create what you don't know. Yeah, I have no clue. Quaternions confuse me enough, man. Like, when I had to do the animation system, it was like, what is that? Like, I was so confused. Now I'm starting to think that maybe it was a combination of things. Like, maybe it is this... Maybe it is that. Oh, also, by the way, and maybe it is that. I also, oh, yeah, it is that. It is 100% that, sir. Whoa. Whoa. Holy smokes. The bit rate isn't going to catch it, but it does look kind of cool. It does look kind of sick. It does look kind of sick. Okay, so what was it telling me? Oh, it was telling me this. It was telling me this. That now this. Okay, so let's keep it a part of the thing, but let's actually fix this. So that's supposed to be that, by the way. That I did mess up. I'm gonna completely admit that I did mess that up. Yeah, the quaternion stuff is very confusing. Okay, so this is still very incorrect. Very incorrect. That's very incorrect. Sir? Man, today is not my day. Today is really not my day. What else did I change? I didn't change anything. Other than that. I changed that to that. That's now the mesh stride. That's absolutely correct. I don't think you need the uint pointer t. It's just that. It's just void pointer. What the hell is this, bro? That's crazy. That's crazy. I guess somewhere I hard coded the vertex layout and now it's like freaking the fuck out. I guess. Like that's my guess. That is my guess. Quaternions was the result of William Rowan Hamilton, which was the accidental direct result of the truth that an odd number dimension cannot be perfect. That sounds insane. That sounds completely insane. I have no clue what that means, to be honest. That sounds like fucking crazy. What do you mean that it can't be perfect? I'm interested in the other, if the other one doesn't work. So here's what I'm gonna do. I'm just gonna get rid of this again. I'm just gonna get rid of that. And go back to the other thing. And then hopefully this just works magically again. Quaternions are just actual 3D rotations. It's actual 4D rotation. What the fuck did I do? What the fuck did I do? Is there an error here? Or? I touched something that I definitely wasn't supposed to touch and now everything is fucked up. Dude. I definitely hadn't touched that, right? having some possible combinations which causes problems, like how Euler rotations can get locked. Maybe it's this times 6 times 6 actually. Interesting. Well, I know that it isn't perfect because like it has some issues. I guess in that sense. Hold on. I might be just going out of bounds of the array actually. That may just 100% be what's going on. What the fuck is happening, bro? Dude, today is not my day. Like, what did I do? Oh, bro. What did I do? Okay. Okay, so I'm not fucking around anymore. What is different in the code between this and that? Like, we're gonna open this up in a split and just go through it line by line. It can't be that. It can't be that, no. Maybe I just copied something wrong in the beginning. The functions are identical, no? Oh, bro. That was it, wasn't it? Yeah, that was totally it. Yeah, that was totally it. Okay. Okay, my bad. One of them was being multiplied times 300. For personal projects, the Euler rotations are hard-coded limits. Quaternions is just another layer of hell, yeah. It is necessary to do like model transformations and like animations and stuff though, because you need the basis or whatever. Okay, so I was just being dumb. That's my bad. Fucking Christ, dude. Yeah, today is not my day, bro. Not my day at all. Okay. So now we can bring back the goddamn normal and okay. Okay. So this initializer should work anyway. We're just not using the normal, but it should work anyway. The only reason it's white is because it's very, very big. Okay. Very, very big. So just like make it smaller. And then let's move on with our lives now because we've figured it out. Okay. So now let's do the index buffer now with that. It was probably one of those things where it was just wrong from the beginning. Okay. So to do the index buffer, we need to do this. This is 6 times 6. Mesh res times mesh res. Yeah. No, yeah, that should be correct. That should be correct. Theoretically, it should be correct. And now we just do this here with I count. That should be fine. Okay. Now let's just take it easy. Just meeting personal projects and wear excuses. Yeah. Just not worth it? Yeah. I mean, it was definitely a pain. I forget why it was a pain, but it was a pain. I didn't use them for everything, but I had to make a layer where it like transforms to quaternion or whatever. I had to do that formula, and I remember that being painful. So definitely been there with it. Okay, so I didn't think that it would take that long for us to get here, but here we are nonetheless. So believe it or not, we just need the first one now, and we need to go to mesh res now because we want the vertices at the end. And now we're just gonna do this here, and then we'll just do this way. Technically, to be the same orientation, it should be like this to what we were doing before. And this increments IC. We don't care about IC. We're just gonna do I count and get rid of this. Okay. Okay. And now to draw it, all we have to do is do this and then swap back to this. Okay. And all the result checks, so yeah, it was definitely painful. It's 100% painful. 100% very painful. Okay. So this goes to I count and not I count divided by 3. So that's what we discovered today, is that I'm stupid. But beyond me being stupid is a whole other bag of beans there. But this isn't working though, even beyond that. And so that means our mesh IDX is probably wrong. Y times mesh res should be correct. It wouldn't be... Oh, shit. No, it wouldn't. No. No, this isn't it either. No, they're wrapping around. God, like how do I even mess this up? Criticizing itself. Yeah, I mean that's just the programmer thing, I think. Basically what I'm doing here is I'm just creating two triangles. As we make one vertex, we are creating the two triangles underneath it, right? For the square, for the quad. But like I'm indexing it wrong, obviously. This O is the offset, the starting offset of our entire thing. So we just add that offset onto it every time. So that's what this is. But I think it's like wrapping around or something. Let's try not going -1. That seems to make it even worse. Maybe it's supposed to be greater than or equal to, but then you're going out of bounds, no? I guess it doesn't matter. No, it can't. It can't be that. It can't be that. It can't be that. So 0, 0. Let's just walk through it case by case. So 0, 0. Maybe I shouldn't be doing this, like, this. How about this? Let's just not do a thing just for clarity here. Even though it should be the exact same thing. Because, like, I don't know. I'm just gonna, you know. This casts automatically, I don't have to do this. It also could be that GL unsigned int for some reason isn't working, and that like maybe it's not our indices at all, and it's like just how they're being interpreted. Oh. What? No, 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 no. Shut the fuck up. 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 Alright, sorry for the profanity. Shut Shut the fuck up. Shut the fuck up. Shut the fuck up. What? And people ask me why I don't use macros. It's because I forget that. Like, bro, like, oh my god, dude. Oh my god. I'm never forgetting the fucking parentheses again in my entire life. I'm not gonna do it. I'm never gonna forget that again. We're getting the unholy series of vibrations known to man. Well, I'm glad that this is over. I'm glad that this is over and we never have to do this shit again. Okay. So I forgot the parentheses in the macro. Okay. So I apologize on that one. That one's on me. What is the rule with the parentheses? Because sometimes you need it and sometimes you don't, I feel like. Okay, so that's the rule with the parentheses. You can't do that. That's illegal for you to do. That's illegal for you to do. You gotta do the parentheses on that one. Now, why that is, I don't know. You gotta ask GCC about that one. I'm not qualified to answer that one, but all right, cool. All right, so that just took us 3 hours to draw a fucking sphere. So, all right, I'm really pissed about that, actually. I'm like very pissed off. Okay. All right, man. All right. Okay. Okay, so that's that. Okay, so now we need normals in here. Normals have to happen. Okay, so how do we do normals from here? We just gotta initialize them to 0. And then, so this creates a normal. We can create a normal like this. Do we want to do the... We want to do the noise first, but let's just do the normal first. Let's do the normals. Yeah, we're not going to have a normal until we actually create the triangle, right? And then we just go into all of these indices and then change this. But yeah, so let's just create the normal for this triangle. I've done this a billion times and now I need to copy my own homework. Yeah, I'm just gonna copy my own homework. That's what I'm gonna do because I don't want to have to look it up again. Yeah, you can blame the C compiler for that one. Maybe I'm just ignorant because that isn't the first time that that's happened to me with the goddamn parentheses in a macro. But everybody always like is like, oh, use macros. Oh, you could wrap that in a macro. You could wrap that in a macro. Like, see what happens when I use goddamn macros is that I forget the parentheses, and then for some reason this becomes garbage. Like, what the fuck are you talking about? Okay, my bad, I guess. What? regardless, we're just gonna copy my own homework because that's what good programming is all about. We can erase this VOD from YouTube, right? I'm just gonna erase this one. This one doesn't exist. Something about, you know, the triumphs being as awful as the not triumphs. The triumphs being as important as the bad times, you know, something like that. Okay, all of this looks correct. This does look correct. Okay. Yeah. I'm just making sure. We also have to normalize it. GCC 15 does it indeed follow the PEMDAS? It does. You know, it's not a thing about PEMDAS, you know, because obviously addition comes before, or, you know, addition comes after multiplication, right? It's a macro thing that you have to wrap the argument in. It's not this. It's not this that's the problem. That's not it. And it's not like this. It's this. Explain that to me. That is interesting. That one's interesting. There's some reason behind it, but yeah. That isn't the first time I've been burned by that specific thing. Anyway, that was like 3 hours of us tracking that down. So that's why I don't use macros. Because I forget the goddamn parentheses. I don't know why that is. Like, it's something about like arguments to a macro that like you need something with like casting it to a type or something. I don't know. That you need to put it in parentheses so that it casts properly or something. This is where the winding is going to come into play, but it all has consistent winding, so should be correct. This is you gotta do dot pause. Okay. Okay, so now you just do it for the other one, which is y plus 1. Okay. And now we just average it into each of these gets a we're just oh my god, come on Helix, work with me today. Nothing about casting is the yeah, it's annoying. I just wrap macro arguments with parameters by default. No, it's not code, but it's just a yeah it is. It's just how it beta reduces after the pasting. Yeah. It's probably something that I'm just too stupid to understand why I don't know, because it's not like this. So this is just, you know, an integer. So I don't really understand why, you know, like why this is why that would be different. Like it's not like this wasn't ever a pointer. You know what I mean? Like that's what I don't get about it. And if that's like, why does this not have to be this too? Like why is it just this in the multiplication? I don't know. Is it because this is a define? I like that. I don't know. Okay, so we're averaging the normals. God, that was such a annoying thing. I did all of the setup right. It just was that. Old new confusion. Wrapping all the arguments. By wrapping all the arguments, you mean just like putting it in parentheses all the time? Like this all the time? That's what I usually do. I usually do exactly that. But it only happens sometimes where I have to do that. But yeah. Yeah, I just whatever. I was just lazy this time because the last time I made macros with that same convention, I didn't have to do it. And so I thought foolishly this time that I didn't have to do it, but then it's one of those things where I just wrote this like in a second. Like I just went boom 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 and then I didn't think about it since then. But yeah, just whatever. Now we just have to normalize. And now how do we, let's just take in the normal. Let's do a normal and then let's just do all right, Blender style, and then let's see if we're correct. Okay. That's fascinating, to be honest. That's fascinating. I feel like that's probably not how it's supposed to look. Just like just like me thinking about it, that's probably not how it's supposed to look. I do initialize them to 0, the vertices to 0. 100,000%. These go to 0. Okay. We could try the opposite winding. We try the opposite winding, I guess. The opposite winding would be, let's just do C0, B0, A0. Now the whole thing is black. Oh shit. Oh, okay, so that's why that's happening. Okay, I get it. I get why that's happening. Okay, so what's happening here is that this hasn't gotten emitted yet. So actually what we should do is we already have zeroed everything. All we need to do is dot pause equals P. There we go. It's one of the quirks of the C syntax. Yeah. Oh, you're gonna make your own flavor of C. That's a tall order. That is difficult. That is difficult indeed. So really this going backwards, I guess, because then you have to do no, you probably don't. Oh my god. It's doing the thing. It's doing the thing. I really thought that that was it. But I guess not. Oh, it's because these pause haven't... Oh, yeah, so that is it. Okay. So we need to do this afterwards in a loop. That's what we need to do. We need to do that in a separate loop. Because those positions haven't gotten emitted yet. Okay. Once again, it's not the code that's wrong, it's the me that's wrong. That's the problem. That is the problem. Okay, so this is going to be mesh -1 or -1, and then you just put this in here. Yeah. Just a fancy wrapper. And then we normalize them after. We do. Basically a high-level language. Yeah, I'm not a fan of the high level stuff, not gonna lie. But that is just what it is. Okay, so it's not this either. The interesting thing is that it's like half of it looks kind of fine. It's just the other half that's backwards. It's like the halves are not correctly oh. The -1 indexing? What is that? What even is that? -1 indexing. That does not seem like something I would enjoy very much. Why do you not work? Oh, you probably don't work because of this. Oh, because we did this. This was supposed to be this. Now we can swap back to this. Yes, exactly. And now we have the ball of normal. The normal ball. The very normal ball. Okay, fantastic. Okay, we got there. It took a while, but we got there. Void pointer P, A pointer is -1. I mean, I get the len -1, but what is the A pointer is -1? What language is that? What language is that? What language has pointers and negative indexing like that? That's crazy. Okay, so now how do we go from here? So now we have to do noise within this. I wrote down what we were gonna do here with the noise. Did I? Oh yeah, so this is what we're gonna do. We're gonna push out by the noise amount, by the height amount. So for now we'll just like rand max times 50, you know, just to see how it looks. Python. A little bit of a spiky ball. Spiky ball. Okay. I would like to get rid of the normal lighting and then just like put in like regular lighting now. Just like cheat it. So we can just, I'm just gonna copy like just like regular blend fong code and then just do that. So halfway dir diff and spec, and then let's just figure this out. Hard coded style. Let's just have a const light dir Fec3 light dir is going to be let's just keep it normalized so that it's fine. Python and MC. For MC, it's actually pretty useful. Yeah, everything in Python is incredibly strange, to be honest. Very strange. We don't need attenuation. Doesn't matter to us. L is normalized dist. That's just gonna be light direction. So we can just like do that, and then view dir. What view dir is from the fragment position to the camera, right? How do you get that again? Don't trip yourself out here. Okay, I mean, technically that's completely fine if we just do apparently that's completely fine. I need cam pause. Okay, and then we get the normal, which is just v normal. Let's just do it for simplicity. Boom, boom. And then we don't care about attenuation, and we're just gonna do why am I ranting about it? I don't know. I don't know either. The negative indexing thing is crazy dumb though. That is one thing is for sure, that it's that. That's 100% that. Okay, hopefully I did everything correctly here. I kind of speed ran it, so we need cam pause. I'm trying to like make up for lost time by like going fast. So that's why I'm kind of going fast. Oh. Sugar declaration of diff conflicts. Diff. Yeah. Yeah, negative indexing is crazy. That is so stupid that that would be a thing. Okay. Interesting. Let's just do it from one direction completely. Maybe you do have to rotate it into... Maybe you have to rotate it like this. Maybe. I think maybe that is correct, actually. Yeah, it is correct. Oh, sorry. It is just negative n equals element count minus n. I see. Is element count the maximum like allocated size of the array? Is that what it is? That doesn't make it any better, but that is. Anyway, now we can do the noise. We can technically hook it into our pre-existing noise function. Oh, seg fault. Oh, because our P is, yeah, our P is obviously not within the, is obviously can go negative, and yeah, so we can't do that. You'd have to do I mean, I can write it in line here. It's not that complicated. It's just kind of annoying. It would be, that's just a lot of parentheses. Be this times 255, and then that for every element. Actually, is it plus? It's plus 1 divided by 2. Just grabs the -2, grabs the element under the top element. I mean, that sounds fine. It's just like overly complicated. Why is it so jagged though? It shouldn't be that jagged, for sure. Not with purlin like that. Probably not. Shouldn't be like that jagged. Unless I'm forgetting how this works. Plus 1 would get it between 0 and 2, and that's why you divide by 2. And our stuff here was always scaled to 255. What the fuck is this? What did I write here? Yeah, it is a bit confusing. It also can't be efficient. It just can't be. That just like screams inefficient to me. Also, negative should be able to go out of bounds. Maybe not inefficient. I mean, yeah, it's just, yeah, it's not inefficient. It's just like, negative should be like a seg fault. %100%. This is from 256 to 256 to 256, so it is, that is correct. Okay. Technically, it should be like something like this. And then you just use n to scale it once. Okay. Yeah. Yeah, I don't understand why they would even think that that's a good idea, to be honest. It just seems like awful all around. Okay, this is working fine actually. You just want to do this like times 50, I guess. This does make it smoother. It still is weird that it goes to 0 in places. That's what's weird to me. Maybe the Perlin noise was never really working under the hood, and we just weren't the wiser about it. Yeah, the fact that it goes to 0 sometimes is very strange. Like maybe the amplitude needs to be lower. It seemed to do like the exact opposite of what I wanted it to do, to be honest. So it's for normal people. It's not for normal people. Normal people need to know the correct way to program. I think that's my argument about it. Normal people need less of a reason to program bad. That's what I feel. Hey, what's up, Mark? Like when you subtract from a number and it goes negative, that can't just wrap around an array. That's not legal. That's absolutely not legal. I know that that's cursed, but like what if I just do that instead? Just to make sure that it doesn't like wrap or something. Yeah, I don't know anymore, to be honest. Yeah, now I'm kind of out of ideas, to be honest. What is that noise function doing? It's Perlin. And the problem is that it just goes to 0 sometimes, obviously, but I mean, maybe it's just that the Perlin was never correct, and that's the problem. I think that our indexing is actually fine, so we shouldn't even be freaking out about it. It's just it has to be the noise that's wrong. So we were supposed to be transferring this this is what we were supposed to be doing anyway today, was not doing that, and instead transferring this to CPU, which shouldn't be like the worst thing in the world, but we are gonna have to figure out some stuff. Like this mod 289 is actually just is actually just mod f with 289. I think so. So that should not be like that complicated. We just do a vec3, and this is going to be we were supposed to be doing this anyways, so it's so I'm pretty sure that we just do that, and then this just goes vec3 scale it by 34, and then vec3 add, I think I'm writing GLSL here. All right, there we go. That's the function translated over. I have an error. I have an extra parentheses, and you need to do a vec3 scale at the end. Look at what this -1 did towards the previously perfect sphere. Yeah, parenthegeti is. I hate it. Like, surely we don't make a mistake here. Surely we don't make a mistake here. And then, like, heavily regret it. This is not a scale. Oh, this is not a scale. This is a mul. Oh. Oh my gosh. I don't have vec3 mul. Oh my gosh. That's such a pain. Okay, fine. We have to implement the mul. Minesweeper 1D, yeah, just let's just pray that we don't mess it up. Mess up one thing here and everything gets ruined and the entire day gets ruined. Why passing vec3 to parameter of type float? Where? Oh, fmodf. Oh, we need a fmodf with each one. Oh, okay. So we can't put this in one line. I know we hate to see it. You hate to see it, but okay. So we get P, and now we need to fmodf everything in P. Alrighty. Okay, that was a little bit painful. Yeah, that was a little bit painful. We can be honest here. That was a little bit painful. Where's the shader? Oh, it's right here. Okay. So now we just have to do this. This is the next step. Okay, so All right. Okay, so this part should be the same. We just have to floor everything in P. I don't think it's necessary to make to do anything there. We can just write it out like that's. Let's just do the floor Fs. Okay. Yeah, I mean, so I'm doing this on the CPU just because I want to, you know, test it out, right? But eventually it's not going to be on the CPU, right? So I kind of hate the fact that I'm doing it on the CPU now, not going to lie, because like look at what I'm about to have to do. Like oh, what I'm about to do is crazy. Oh, what I'm about to have to do is crazy. Oh, you hate to see it. You hate to see it. Okay. Okay. Yeah, that's correct. Right, and why are these all vec4s? Is it really necessary for these to be vec4s? I guess so. Hidden conditional go to time? I don't think we can do that. Unfortunately, I just feel like that would be stepping a little bit too much onto the dark side. So what the fuck? Oh, right. No, that's completely fine. I don't know why I like had like a mini mental breakdown there. It's completely fine. Yeah. I don't have vec4 ads. Yeah, that's gonna be a problem. Easy. Just took a second for us to do that. That's fine. Vec4, vec5. Nah, that's too many. All right. I feel like this is how what most people think like coding is. Just like typing really fast. Just like yeah, this is not coding. This is, I don't know what this is. Yeah. No doubt. Okay. I love for loops. Do I? Or go-tos? I'm not a fan of go-tos personally. I've used a go-to like a few times with some funny loops. Some very funny loops I had to do. Okay, so perm has to take in a vec4 actually. So all of that has to be a vec4 actually. Yeah, perm is always a vec4. Yeah, perm is always a vec4. That sucks. Because now we have to implement literally all of this. And then perm returns a vec4. Yeah, we have to implement literally all of these in vec4 form. You hate to see it. Add, scale, and mul. What? What? What did I do? Ah, that's what I did. Okay. Done. Done. Very fast. In and out. Not the burger. Coding is configuring a system. Programming is creating the system. That's deep. That is deep. That is really deep. That is pretty deep. I feel like now I'm thinking a bit about myself now. Am I a programmer or am I a coder? That's a good question. Okay, so what is this? Use of undeclared identifier K. This has to be K1 then. Right? Yeah, no doubt. And K2 is a drug, but that's alright. Okay, so then we go perm C plus that, so it's vec4 add. We're eventually gonna make this a compute shader, but for now I'm just doing it. That is adding, so we have to add. Very good, yes, it's adding, so we have to add, very true. Yeah, so that's that plus that. That plus that, and then K3 is that, and then this is a comma, and then the fract, I already did the fract over here. Okay. Conflicting types. Previous implicit, you're an implicit. We need to do a fract for a vec4. They're useful and even preferable when creating self-cleaning functions. Yeah, there's a error cases, yeah. The questioning of life choice case in programming. That's a very deep statement. I feel like I'm not qualified to even handle that statement. Okay, I think I got it. It's like when you tell a joke and then the other person doesn't get it. I'm having to think about it a little bit. You handle the case when you're coding. And so we now handle the questioning of life in programming. But when you're coding, you actively are handling cases. Is that the correct answer? That's probably true, right? I can't keep up. I can't keep up indeed. I did that backwards. And we're gonna return P from this. And that's that. So vec4 fract. And then we have to do the internals there. And then this is a gauntlet here, so that's scale. This is, oh yeah, this is cursed. This is incredibly cursed. It's incredibly cursed. Why is that not a constant? Whatever. I'm not gonna question the people who write shaders. They're smarter than me, as we know. We're gonna scale this by that. Vec4 add that to that. And then this is a vec4 scale that by that. This is a vec2 mul. Okay, vec2 scale, vec2 scale. Okay, got it. I'm there, I'm there. I'm right there. Vec2 scale. Vec2. The answer is that there's no joke. My autism mental health is unhinged. Damn. That's alright. I mean, I say random fucking shit most of the time when I'm here. I don't think it's unhinged. It's probably just too smart for me to understand it, to be honest. It's above my... To be honest though, I miss every single joke. It's kind of like just what I'm known for, is just missing jokes. So it's nothing new for me. Nothing new at all. Okay, so we need a vec2 add and then we're done. Oh my gosh. Are we actually out? Okay. Okay. To add. Okay. And now the FBM function. FBM function is here. This is the easy part. Or it looks like the easy part. Why do we have errors? Initializing... What? Oh, I meant to return vec4. Okay. That's simple. I know we have an error here because we are missing a parentheses. And then this is too many arguments to function call. Because that's supposed to be vec2 that. Fantastic. Go to is simply just a jump. Yeah. I see. Yeah, exactly. Exactly, yeah. You gotta do them in order. Yeah, I mean it's alright. It's just like I always feel like I'm gonna mess up when I use a go-to, but you know, what do we even return out of here? Oh, we returned something that I didn't do. We returned this, which is it's actually just o4.y times d.y. Yeah, it's actually just that. Okay, that's not that bad. Okay, and now FBM is this. I don't know why I did the shift here. Like, what was this? I'm not sure. I think that I put that there. I don't think that anyone else put that there. I think that that was actually me put that there. Num octaves is 5. And then we're just vec3 scale by f, and x is p. I'm definitely making a mistake here somewhere. We're doing f there, and then why is a here? A is here. Okay, and then what, we return v. Okay. Okay. And then this is FBM noise. Okay, I've no clue if we did it. I remember. Okay, I coded it. I didn't program it, I coded it. Multiple definition of perm. I left this in here, didn't I? I did. Simply incrementing a byte with each successful sub-initialization, then jumping to a main switch. Upon the current sub-initialization, returning a 1. It's a lot cleaner and efficient than having end switches with ever-growing cases. Yeah. I get you completely on that. I get you completely on that. It's just not often that I have like cascading memory inside of each other, I guess. It's just not very often. But hey, look, I mean, it's kind of a planet. And there is a seam here, which is kind of annoying. It's actually not an actual seam, it's a normal issue. It's just the normals don't get averaged across the border, which is sucky. It is sucky. Okay, so I think that I did it correct. Now, do I have like any way of knowing if I did it correct? It would be really hard for me to actually. The result is pretty decent. So I'm gonna assume that it's correct. Vec 3 mol dt. Vec 3 mol times mol. Yeah, that's correct. PA. Like, to my eyes, it looks fine. Just return 0 before the switch and go to label. Yeah, that's how they do it in like the Linux kernel, I'm pretty sure. So it's just not very often that I end up with code that would make use of that, I guess. Like the stuff that I do, I typically don't even malloc stuff like 90% of the time. Yeah, I get it. I've seen the code that does that in the Linux kernel, so I completely understand it. Or I mean, not like completely, like I'm kind of stupid, but I do kind of. It isn't unfamiliar to me, the concept, so I get it. YWXC. Yeah, I wonder if this is, so this is shift 100. I don't know if I'm supposed to be shifting 100. What do they shift by? They do shift by 100. And num octaves is 5. Okay. I mean, it's not like the result is bad. I think the result is actually what we expected. So I think that's solid. Now I kind of want to try mesh res 64 and see what that looks like. Maybe like increasing the resolution will look better. Yeah, that's getting somewhere. That is getting somewhere. Now I guess it's about shaping the noise in the same way that we do it here. Like, I have a lot of stuff to shape the noise. Specifically, warping is like a big thing. So let's go warp it. Let's just warp it for now. Let's just warp. Warp. Right, so we just have to yeah, I think it does get like too much hate, to be honest, as a thing. Go-tos by people that just don't understand it. Or not understand it, but see the use case. Just because, like, I don't know, somebody said that it's bad or something. I don't know. Okay, so that warps it. Now, how do I use the warp again? Okay, and then I put this back into the function actually, so and then I put P2 Operator overloading might be kind of nice at this point. It might be a little bit nice. Resource conservative. Basically assume the stack is 1 kilobyte. I see. So you use a lot of. Are you doing like arena allocation or anything like that? Okay, so we're adding P to the warp scale, yeah, and then we put it back into the thing. That's what we do. We feed it back into FBM times 6, and then we pow it with 3. That's how we do it. So and then oh Jesus. Oh geez. Maybe not the POW. Maybe not the POW. That is pretty sharp. That is really sharp, actually. It's not supposed to be that sharp. Maybe I did it wrong. I transcribed this wrong. And then times 2. Now that is correct. The warp is correct. The surface level functions are secretly some pushes into a 1 kilobyte. 1 kilogram, 1 kilobyte. No need for argument passing. Interesting. Yeah, it's hard to like think about what that entails actually. Yeah, it doesn't look like that usually. Like from here it doesn't ever look like that, to be honest. rewarding for not only possible architectures. Yeah, it does seem pretty insane for, I guess, speed. I guess speed. Maybe I did the FBM wrong. I don't know. Put this onto a 1 kilobyte compiler allocated buffer. Yeah, scale wouldn't change anything other than the size. Or not, why am I doing that? Maybe I like offset it by some amount. Maybe it isn't like, maybe it's different in now that we're in 3D, that the noise has to be shaped differently. Like that's the frequency, right, that we're doing there. And then this would be the amplitude. So maybe the key is just to keep the amplitude really low. Okay, well that just deleted the whole thing, so. 1 kilobyte is the default. Okay, so why is that a thing? Yeah, it's hard for me to like visualize what that, if it's 1 kilobyte. So you're telling me that the functions themselves are getting pushed. That's what you're talking about. You're not talking about actually like memory itself. You know what I mean? So maybe that isn't. Maybe that's amplitude. Maybe that's amplitude, I guess. I thought that amplitude came after the thing though. You know, something else that we could try is like change the amount of levels. Here's something. What if we do F plus 50? Instead. Oh yeah, now that's totally what we meant to do. That is totally what we meant to do. And then you just multiply this times some value. That is totally what we wanted to do there. You can't just make it all noise. You have to... Yeah. That's more like it. That is more like it. That is more like it. The functions are secretly just defined. The function's arguments are moved. Oh, I see. I see. I see. I see. Yeah, adding the ampersand does make a bit more sense. I see. So you're just I see. So you're literally just like, it's literally just a, is it like a register kind of sort of thing? It kind of seems like a register. Maybe. Anyway, we can do some playing around with it now to get some weirder things. How many vertices is this? Probably a lot. Probably a lot. Registered, but on a guaranteed sheet of paper instead of actual registers. Yeah. I wonder if is that how like things happen under the hood and some other things? I don't know. Like, do, arguments just get pushed onto the stack just normally? Like, I don't know how that actually occurs. Like, is it copied to the top of the stack usually or something? I don't know. If I can compile, I can run. I see. So you never run out of space, I guess is the point. What happens if you need to copy something? Oh, but then you said that it can be resized. That is what you said. That is what you said indeed. Okay, so that works. Syscall savings. Yeah. Yeah, the normal stitching is gonna have to happen. I wonder how far we can push the resolution here. Like probably 128 crashes the computer. Like, do you think that 128 crashes the computer? Oh my god. We're starting to lag a little bit, but it's crazy. 128 is a lot. The lag doesn't even show up. It feels laggy, but maybe it's not. You don't know how many recursions you're able to redo. Oh yeah, that's true, because you can only do it on the top level, basically. I see. I mean, I feel like that's a fair concern. You know, that's a fair concern. Now the question is, I guess, I mean, so now we've meshed our first planet, so that's cool. We've meshed our first planet. That should not have taken as long as it did. I feel really bad about the you know, the issue with the fucking macro. I'm not gonna lie. That really did put a damper on things today. Not gonna lie. That isn't the first time I've had a bug like that though. So it's whatever. Anyway, we've meshed our first planet. Stitching the normals would be easy to do. All we would have to do is we could store offsets for each face and then just iterate it afterwards. Oh no, we duplicate the vertices though. That is true. We do duplicate the vertices. It would be easy for us to do. We'd have to decide on a way to do it is all. We'd just have to decide if we want to, you know, do like -1 and then we stitch across or something like that. It's very doable. It's just, I'd have to think about it. Project looks visually, the hard part is basically nah. The next part is that we have to walk on it. That's the next part. User level API, not a whole OS. Yeah, you would need OS level control to, I guess, do that. Especially efficiently if you're gonna think about the stack and the recursion thing. Yeah, we need to walk on it. We have normals and everything. We just need to do collision now. And the question now is like choosing a system for collision, I guess. Like, do we want to do voxels again or what? That's the question. User level or bare metal with a framework wrapper provided by NCappa. That is... a framework wrapper. If you're, I mean, if you're bare metal, then you're bare metal, no? Wouldn't bare metal give you OS level control? I guess. Yeah, I don't know how we're gonna do collision next. I feel like, so I could just like do voxels over the entire thing and then spatially put the triangles into those voxels. That's the easy way to go about it, right? Is that like when we emit a triangle like this, we just find the actual location for these this triangle, and then we slot it in to there. And so when the camera is, you know, in that location, then you just look up that triangle. But there's a lot of edge cases with that, naturally. So, hello still. Hello, Max. Hello indeed. You want to see how it's looking? We made the moon. We made the moon. First programmer on the moon. Look at me, I'm on the moon. I'm on the dark side of the moon. Shout out Pink Floyd. The problem is we want to walk on it, and now I'm trying to figure out how I'm gonna walk on it. Obviously, also the idea is like you click on a planet and then it just makes this into its own thing, but I haven't implemented that. Like, the idea is that like we take all of this shit and then we put it into that. This is not cheap on the CPU though. This probably, we don't know how long this takes, but we can implement a timer just to see, but it probably takes a while. Like, we can actually, let's do the timer on it to see how slow it takes. So timer check, let's go implement textures, normal depths. PBR? No, not PBR, but I mean, it already has texture, normal, and depth. Like, everything has everything. In a project like this, like, it's not a game engine, so I don't actually have to do a framework for anything. All I literally have to do is vertices and map them to textures. Like, it's not very complicated because of that reason. Why am I writing a for loop? Okay, let's see how long it takes. What, scared? Oh, about PBR? No, I'm not scared about PBR. It's just not necessary. Like, I can just fake it with specular. Like, there's really no need for, I mean, maybe eventually, but I don't know. Not with a project like this. I just don't see the purpose of it. I can kind of, the noise kind of does it itself. So this is that 11 milliseconds or 11 seconds? I think it's 11 seconds. Why am I doing it multiple times? Oh, for each face. Is that really seconds? I think it gives me seconds. I think it gives me seconds. I can check if it gives me seconds by just like doing a timer here and then just like seeing how long a frame takes. Oh yeah, we already have a timer here. So let's see how much master says. Oh, it's milliseconds. What the fuck? This takes this little time? That is crazy. Wait, why is that so fast? Our CPU is actually strong? What? That's crazy. That's actually crazy that this happens in 10 milliseconds. Nested looping across the entire face. That's nuts. Need a few more polygons? Yeah. Yeah, I mean, so the idea is, Max, that the idea is that this is just the exterior view. So when you select a body, it's just going to render this on top of it, right? Just to give it detail. But this isn't actually what the mesh that you're gonna walk around on. Like the mesh that you walk around on is gonna be like chunked and marching cubed. So this isn't actually the real final thing. It's gonna take a long time to get to that because I have to actually marching cube the whole thing. And that's gonna be hard to do. But for now, I just wanna kind of walk around on it to be funny. Modern day computation. Yeah, this is gonna be in a compute shader anyway, so it's not like I'm not gonna sim it because there's fucking no point. It would take forever to sim this, by the way, but I'm not gonna do it because I'm just gonna put it in a compute shader anyway. Eventually, this is all gonna be compute to be fast. I eventually want to push the mesh res. I kind of want to see how far I can push it now. Like, we can push the resolution to crazy then. Like, I mean, we're actually memory bound is the thing. Like, that's a lot of vertices. Rob? Don't test me today, Rob. Do not test me. I had a macro issue earlier, Rob. I'm not in a good mood. I'm actually in a bad mood because of the macro issue. So don't test me today, Rob. I had a macro mishap. You know about that? A macro mishap? I had a macro mishap. A macro mistake. Claude wouldn't have let you have a macro issue? You're right. You're right. You're so right, Rob. If only I had a Claude subscription. Yo, Rob, buy me a Claude subscription. How many bytes does one vertex take up? Not that many, but you gotta think about how many we got on this thing right now. We got a few vertices, bro. We got a few. It's a Vec 3 and then the normal. So 32, 32, 32. I don't know, bro. You do the math. I mean, we could. I mean, they got a lot of vertices on like rocks nowadays. You know what I'm talking about? They got a lot of vertices on rocks. Nowadays, they got like a rock with like 2 million vertices. So I feel like we could probably push it even more. Like if we go to 1024, what's the point where my computer explodes? Now that's gonna take forever. Yeah, that was a bad idea. That was a bad idea. You make F1 cars on Blender with 4 million vortexes? What the hell is a vortex? Yo, get Rob on that ASAP. Yo, Rob, ask Claude what a vortex is. Holy shit, bro. Alright, now we're feeling it. Now we're feeling it. Now we're feeling a little bit of lag. I got so many vertices on this, it has an aliasing issue. Holy shit. Oh, you just misspelled vertices. Now that kind of looks like a planet. I'm banned for Claude for token wastage. How did you waste tokens? How can you waste them? I'm glad you're clean, Rob. I'm glad you're clean. Anyway, so yeah, next is collision, I guess, for the test. I'm trying to get mountains and shit, you know? I'm trying to get mountains and shit. I probably have to like take more like time to actually, you know, do it. Vibe coding is not a joke. Vibe coding is very serious. Dude, don't talk about vibe coding with Rob here. Do not talk about vibe coding with Rob here. Rob is gonna beat you up. How do you hard code displacement though? How to do that with nodes? What do you mean displacement? Like moving something? Are you talking about moving something? You have a model matrix and then you move it. You add numbers to it and then it moves. Alright, so that's the opposite of what I wanted. Okay. Anyway, I'm gonna probably take a break and then be back later. Texture displacement. And mountains. Well, you got these UVs, and then they move the UV. More like bumps and mountains. Texture displacement. Displacement? I have a noise function, and it puts noise on the thing. That's what it's all about. Try, fail, repeat until working. That's what I do all the time. Hey, this kind of looks good. This kind of looks good. These noise with your how long will that break be? I don't know, probably like hour or two, and then I'll come back and I'll do my hand at collision. See, and that's my GPU. Oh, the mobile 1050. Come on, Rob. Shell one out so that I don't have a mobile 1050 anymore. You'll be fast asleep. Where does that saying come from? Fast asleep. Where does that saying come from? Fast asleep. You know what's also crazy is that like when we have a planet like this, how are we gonna deal with gravity? That's a good question. English is not your native language? Oh, I would have never guessed. Yeah, so we need to be gravitating towards there. So our up vector is never going to be up. Damn, that's tough. Our up vector always has to be tangential to the middle, right? And so okay, so this might be actually more complicated than I thought. That might actually be more complicated than I thought. Because like in my game engine, for example, gravity, you just like subtract from your z velocity. That's all you do. And then you go down. But now we don't do that. Now you have to subtract a vector that is the direction to the center. That's not that bad. That's not that bad. I guess. Is your English really not good enough? Your English is better than my English. My English sucks. My English sucks. Okay, so the easy way to do this. So here's what we're going to do. The mesh vert, by the way, this pause is not by view. This is going to be the model matrix. The model matrix. And the model matrix is going to be just the position of the particle itself. The position of the particle itself. And to get that, we can just like bring in particle data and the uniform for the hover for the selected particle, and then bind that uniform, and then we can mesh it. However, I'm not really sure. Where do I take this in as a uniform? 100%. Oh, it's not in here. It's in here. Or it's not in here. It's inside of post-process frag. Because that's where I draw the... Yeah. That's where I draw the line. That's where I draw the line. Yeah, so now we just have to multiply, or maybe we just offset this position by, maybe we don't even have to do a model in matrix. Maybe you just offset this position by pu selected dot pm dot the pm. Dot xyz. Yeah. And now let's turn the simulation back on. Fuck. What did I just do? Did I? No. You're not that comfortable yet? You're really good at English. Watching YouTubers and just, you're sweet at, wow. Yeah, you're really good at English. You're better than anyone I know at English, actually. Very, very articulate. Very, very articulate. So we're just gonna send this into here, into mesh shader, and we will, we won't draw anything. There's no point in drawing anything. Let's just actually keep this simulation going. Or yeah, sim step is already happening. So now we should, the body should move. What? Uniform undeclared. What? Oh, I did. Okay, so we have some issues. Undefined variable body count. Got it. I'm right on it. I am on it. Okay, just this and then I'll take a break. You think in English. Oh, that's interesting. I couldn't imagine not thinking in English, I guess. Oh, you know what? We aren't actually pushing the entire position. We have to do this here because we're not actually, that was just the normals. What is it? You have the words in your head and then the whole sentence constructed? Why are you not moving? Yeah, I think it just is like a brain issue. Like I've had a lot. I didn't have it when I was younger. I think when I got older, it just like started happening more, where I just like can't focus on the words that I say before I say them, sort of thing. I think 0 should automatically do it. So I'm not sure why that's not working. 0 should also. Yeah, I couldn't imagine being dyslexic, I guess. Oh, I know what's happening. I know what's happening. We got rid of all of the particles. That's why. I think it should be moving faster than that. It is moving though. I'm trying to select another particle. It is moving though. Uni getting absolutely mogged tomorrow. We ain't stepping foot. What does that mean? We ain't stepping foot? Am I a boomer? What does that mean? You ain't clocking this? I'm standing on business. Alright, I have to take a break. I just want to get this. It should probably be moving faster than that, I feel like. Okay, maybe it is moving fine. Yeah, now it's kind of picking up speed. Okay, there we go. Now the thing is, now we just scale it by... Oh, but we don't actually mesh it with the... We have to take in the particle and then scale it by the... Scale it by the radius of the particle. That's what is going to go here. So that when we display it in the universe with the other stuff, then it looks fine. I don't even know if what is mad? Oh, that's mad. Main VAO, main VABO, yeah. You want to ask me something? Me? You can ask me anything. It should be impossible to miss this thing. Oh, it is impossible to miss this thing. Okay, it's a bit large. It's a bit large. The biggest body in the universe. Okay, so it is moving at the same... Yeah, it is moving fine. Learn C++ from Zero book for Herbert Schilt. I want a Deep Diaper. Oh, English is my first language. There goes the GPU. Dive deeper into C++. What's the next step to go deeper into C++ than a book? I'm not sure. Whatever you do, don't watch Coding Jesus. That's for sure. I think you're pretty solid on everything else. Like, a book is probably pretty deep. I mean, I think just go projects, you know? Just go projects, try and learn the new features or whatever, like, I don't know, whatever, the namespace stuff and the, you know, all the C++ shit. All the fancy stuff. By the way, the simulation runs at 200 FPS. It's just my my laptop is overheating because it doesn't like me very much. But yeah. So we can either scale a model matrix down and then that scales the whole thing down, or we can just scale the actual radius down when we generate the mesh like this. Like this takes in a particle P. So technically we could just do it when we select one and then we just pass in P into here. And then just this becomes P dot. Oh, that's namespacing. Okay, I have to dip out here, but particle.pm.w. And then that should be that. But this isn't the actual radius. The actual radius is calculated by doing this. It's actually this to get the size. And then, so this is size. And now you just call this function whenever we select a body. And the function we call when we select a body is we don't call a function, but we do handle the input. We handle it here. And now all we do is we're just going to do exactly that with the particle. We just do this, and then the particle test we have to fill in with, we have to read it in like this. We're gonna read in a particle into the thing. Yeah, sorry, I'm rushing through this because I need to eat dinner and dip. So this is going to be a particle pointer, and we're reading, we want this, we get the offset of size of particle, and then we read it into here, and then we read this into test, and then we mesh with test, and we undo the buffer. Okay, technically that should be it. Also asking your server, but projects are the best ways to go. Yeah, exactly. Okay, it did mesh it a bit weird, not gonna lie. It did mesh it a bit weird, not gonna lie. Why is it meshing it a bit weird? Not gonna lie. I have no clue. I have genuinely no clue why it's different than if it's just at 50. We could try not doing it at the beginning. It is sad that we can't just do our painting of our canvases forever. That is truly a big bummer. I relate to that a lot. I wish I could just do that. That would be awesome. What if we do it not based on the size? Why is the size free invalid pointer? Hate to see it. Hate to see it. Okay. So So doing it based on the mass is a no-go. That's an invalid pointer. You hate to see that invalid pointer. You do. You really do hate to see it. Yeah, I have no clue. This size should be consistent across everything. When we call this multiple times, it should be, this size should be absolutely consistent every time. Like, size should never be changing. Particle P. PM.W. Size. Yeah, I'm not sure. I am not sure. I'm not sure. I would have to actually like print out and make sure that somehow it's not changing. Like it wouldn't look like that if size wasn't changing. Okay, I'm out of here. A frozen supernova? Thanks for making it seem epic. Okay, so size is always the same. Size is always the same. So, oh, it's just very tiny. Oh, it's just very tiny. Oh, that's why. Okay, well, I see what the problem is now. Okay, well, maybe there's nothing I can do about that for right now. I think it's just less than 1, and that's making it angry. So that might just be a problem. That one might just be a problem. Okay, there we go. Okay, there you go. You got it. You got your little thing now. So there you go. You can be happy that you got your little thing, and I can go eat dinner and have peace. This is taking forever because I printed it out. I don't know. I printed it out and I was stupid, so my bad. My bad. My bad. But now the orb is the correct size. Okay, that didn't make it. Bro. Bro. What? Okay, well, I broke it. So. I broke it, so. And now there's an invalid pointer. So. Alright. I gotta figure out why that broke it. But. Yeah, we're gonna have to take a gander. I'm guessing that it somehow got the wrong one at some point. Whatever, I'll figure it out later. And then we're gonna color it and blah 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 blah. Oof, broken pointer. You're a broken pointer. Let's fix that broken pointer right now just so that we're happy. when we press escape, what happens? We get running to 0. And then when running goes to 0, what do? We delete context and destroy window. Okay. So you're telling me that we don't have a context? Huh? We don't have a context? Alright. Yeah, whatever you say, bro. Whatever you say, bro. Like, what are you talking about? We don't have a context. What do you mean we don't have a context? Of course we have a context. What? What are you talking about? What are you talking about? What are you talking about? Whatever, bro. Well, you get the window, you get the context. We get the context. You're telling me we don't have a context? No. No. Alright, whatever. I'll see you guys later. I might be back later, but I may also not. I don't know. Next time's gonna be collision, I guess, and gravity, in terms of getting the camera gravity on it. But thanks for hanging out. Hopefully next time I won't have a macro issue. I can't believe that was the bug. That really was sad. Alright, peace out. Join the Discord, etc., etc. I will gotta go back to actual work now. Yeah, thanks for hanging out and talking. I appreciate the fucking company. That's the whole reason I go live. Otherwise I would just do it in quiet, you know what I mean? So it's almost 3 a.m. Yeah, go to bed. Go to bed so that you can do well in school, mister. All right.